kindly introduction, which is totally correct. And I also enjoyed hearing what Claudia was saying about what you're currently doing as a tool for immersiveness and how this could have an impact in order to research more scientific questions, also consciousness, for instance. So maybe we can connect afterwards also to such topics, because it's also interesting for us why we are using VR as a technology for evaluation, for instance. So I would like to share a few slides only and a very short video to give you a glimpse about what am I actually doing at the research lab and what are the main questions that drives my curiosity for research. So I will share my screen now. I hope you can everybody see my screen. So, and the main thing that you see is, of course, my main interest is
Matthias, we don't see your screen.
Oh yeah, I have to now teilen. Now you see it?
Yes.
Okay, perfect. Sorry for that. Yeah, so the main thing that drives my curiosity, as you probably have heard already, is about the brain. And the main thing that I'm interested, how can we connect brains with machines? And the subtitle already, what you see here, could be framed like a claim or a question. So the question would be, is the mind actually the next frontier in science? And is this the last thing that we have to solve scientifically? So about the experience, about consciousness and so on, what we already heard. But on the other side, we can also say from a technological perspective, if we want to connect humans and machines, the mind could be the next frontier in order to solve this ultimate goal that some also have in mind. If you hear about, for instance, and transhumanistic talks and also posthumanistic talks, for instance, from guys from the Silicon Valley who envision something like going beyond the human and being something more technologically optimized or enhanced. So the question that drives me, and this is also where I'm heading the lab, is about neuroscience in complex environments. So complex environment means it's not like strictly controlled experience, what you normally do in neuroscience, but we want to understand the brain in everyday life and also at work. And this is why I call it here applied neuroscience. So as Liz already nicely said, so that the main research angles from my lab are like bringing together cognitive science with positive psychology in order to enhance the well-being and also positive user experience at work. So we want to reduce, for instance, stressful moments and see how we can leverage the full range of human potential during the interaction with technology. And we combine these with machine learning approaches just for a better understanding of how to interpret these neuroscientific measures or neuroscientific signals that we are recording during the interaction. And the goal is, as to empowering people, we use physiological measures, so to say, as a proxy to the mental states. So meaning that we have on one side a measure of the brain activity, we can somehow correlate this to behavioral aspects like motivation, cognition, like attention, workload, but also emotional experience. We have heard also a lot about experience, how art can create experience. And this is also what we want to understand. So more from the user perspective, the emotional experience from such measures. And the envisioned applications are twofold. So one thing, it's really straightforward, like an evaluation and improvement of human machine systems. But on the other side, to also apply it for neuroadaptive systems. What I mean by this, I will show you later. So the main thing, what I'm doing is going from the lab to real world application. So I really want to understand what are cognitive and affective processes in such environments. And for this purpose, I use such unobtrusive and non-interruptive technologies just to identify task-relevant information from the person with not disturbing the person. And this is what I want to use to foster a better human-machine partnership. So the last thing that I just want to show you here, and then it's also done for my slides, is to give you a video showing you a brain-computer interface. So here in this video, you will see interfaces to the mind that we are using. For instance, we combine virtual reality with a brain-computer interface. So the task for the person that you see here, the user should play a video game or should play a game in VR, and this game is controlled just by mentally activity. So the person should, in several rounds, try to relax, so calm down and relax, so try to think about inner mental states or something like mind wandering, or also what you do during meditation. And on the other side, try to do a concentration tasks. And you will see how the person is solving this. So what you see here is now the person is wearing a headband here, which measures the brain activity, so electroencephalography. And here you see the raw data of these signals. So we use these signals with machine learning in order to identify two states. So one state is relaxation. So you see here these balls, they are more like distracting the person, and the person should ignore these balls. And by relaxation, the balls here are slowing down, and this is feedback to the mind state of relaxation. And on the other side, then the next step is try to concentrate on how often this ball is blinking in a particular color. And this is a concentration phase, which is also feedbacked here. And the better the person counts here, this is also reinforced, so to say, that the person gets in reward by how good the counting was, and then can select these balls here by just visualizing them here in VR. And this is like you don't see the last part here, but this is the last part of the game, that it can also then fight against this bigger ball in the end. So it's like an end game, or the big ball is, so to say, what you see here. You have to defeat this big ball, so it reduces also the level here. So what you here nicely saw, and I stop also sharing now here, was like we use these technologies as a proxy to interfere the ongoing cognitive processes, and use different environments as evaluation tool. And what drives me during this is, as you probably have seen, is that it's the relationship between computers, or rather saying machines, and humans. This was already from the beginning from my studies. And my impact in my research is also like not doing only basic research, but also having something for applications. To give you an example, also during my research studies in Tübingen, I was interested on one side on basic research, trying to understand the functionings of the brain, like the motor system, but also on the other side to develop a special neurofeedback application, as you saw, for instance, here, for people with stroke. So, and this was mainly done by controlling a brain-robot interface environment. So the person can do a rehabilitation program in order to regain motor functions after stroke. And this is actually now used also in rehabilitation programs, for instance, at the University of Tübingen. And after this, so I decided, okay, so my main research that drives me now, or more generally speaking, is, okay, the important question of how we humans and machines will interact in the future, or how we will also work together with computers in the future. And also an impact on this is how will these, like to say, familiar processes will change, and what kind of social implications can this have in several contexts. So this is more like the approaches and the general thinking processes, what the first question was on. And what I'm especially curious about is if you see, for instance, this tremendous progress that we have right now. So for instance, we see a lot of digital connected systems surrounding us in our daily life. We see more and more methods of machine learning also entering our everyday life. And in general, what we do is we develop such technologies in order to satisfy intentions, right? So we want to see how we can anticipate our needs, and thus making our life easier. So this is what we would see is that we have machine learning tools in order to have automated cars, for instance, or also computers that trade our shares, for instance. And from a cognitive neuroscientific perspective, if you look now at technological trends, like for instance, voice interaction, gesture, and even thought interaction, which we are not that far away right now, is that this will also increase our interaction of the symbiosis between the human and the technology. And this is what scientists say, this could be a new phase of interaction that we're entering, like symbiotic intelligence, what we would see. And this will also gradually change our way of experience, as we heard before. The more we have interaction with technological products and services, this will have a tremendous influence, as I see, on our sensory motor skills, but also on our capacities and cognitive skills. And on one side, I'm really excited about, as I say, about such concepts, for instance, of cognitive augmentation, which very broadly describes technologies that we use in order to enhance our skills, in order to enhance our motivation, in order to fulfill our aims and goals that we want to see. Yeah? The very easiest things of cognitive enhancement are, for instance, computers, but also our smartphones that we use as an extended mind, but also as some technologies in order to reach up memories which we not have to in our mind, but we somehow can have it via the access to the internet. So this really excites me on one side, but nevertheless, on the other side, what is also important that we see due to this integration of technology in our everyday life, we have really challenges and potentials for conflicts, for instance. So as we see it, and this is also why we are on our institute are interested in a human-centered approach, is that what you see usually is that humans with their individual preferences, with their individual skills, they find themselves overlooked by purely looking at a technological approach. So if we develop future technology, we should have always the human in mind and the humans in the center of the technological development. Because on one side, if we look, for instance, that the resulting solutions, they can be technologically good, but nevertheless, they have often limited gains. For instance, if you look at productivity, if we look at creativity, but also at health of the user in question. So this is why, on one side, we should not get out of focus of such a human-centered technological development. Yeah? And by having this, I mean, and this is what really I'm curious about, is to have really an optimal design approach in mind that I can use for my technological development. So technologies that are really geared to the user needs, to the preferences, in order to have really an efficient and an acceptance technology. And from my perspective, what I'm also curious, and this is what also was said before, is by having such interactive technologies or cognitive technologies, I'm asking myself, how could it be that our learning is possibly changing? How do we learn in the future? Also with having more and more digital learning environments, for instance. The question is also, how is our experience changing? We don't know right now, but we can explore this with such technology. And last but not least, also, what about our happiness? So how is this changing by having more and more immersive technologies entering our everyday life? So these are the main things that I'm curious about. And I think the last question, what I really want to answer from Liz, was what modes of learning and collaboration was I'm discovering during the recent times. And it's really something excited is our current ongoing project of Brain Palace, which Liz shortly said something about, where we can also explore, which I think it's also one of my main goals, neuroscience in complex environments, because this project nicely brings together on one side arts, but also design people behind this. And in this Brain Palace project, to make it really quickly, is we're working together with media artists from Berlin, but also with the artists from Munich, where our idea is, can we measure in an artistic environment via BCI, for instance, the interaction of two persons' brain activity. So we want to measure their interaction in such an environment and want to see, can we bring or somehow are the people on the same brain wavelength? So what we want to measure is the synchronicity between the two persons that are interacting. And the more they're on the same wavelength, we give them a feedback via the art installation. For instance, the light environment is changing, but also the audio environment is changing. And we ask ourselves, by having such an immersive environment, by really controlling the environment with the synchronicity of the two interacting people, is this enhancing also empathy? So can we somehow increase the social closeness and the connectedness of the two interacting people? And this is really something that I'm curious currently, which I see that without having such an interaction with the artist, we cannot ask so freely such questions, because if we would do such questions in the research lab, we are more restricted to really controlled laboratory environment, strict protocols that we're using, but here we are more freely also in the interaction and how the people are meeting together in such an artistic environment. And this is really interesting, I think, during these days. From that, I would say that's from my side, and I would now hand it again over to Liz.